Right now, there is an invisible, high-speed flow of data constantly racing between local cell towers and the device in your hand. Telecom companies market 5G as an absolute speed multiplier. You pay for the upgrade, and you get a dramatically faster pipeline. But we have to ask a practical question. Does a massive, theoretical jump in speed actually translate to a tangible improvement in how your phone behaves? This baseline comparison table shows standard 4G delivering 70 megabits per second down and 9 up. The 5G connection delivers 812 down and 60 up. That means an 11-time increase in download speed and a 5.6-time jump in upload speed. But there is a major flaw with these numbers. They are synthetic benchmarks. The apps you use every day rarely behave like a benchmark test. To find the actual value of a 5G connection, we designed a series of real-world bottleneck tests. We locked down the variables. First, every single test was run on the exact same smartphone. Second, both the 4G and 5G connections were tested on the exact same telecom network. And finally, all tests were conducted standing at the identical physical distance from the local cell tower. Real-world utility depends on how a network handles software bottlenecks when hardware is pushed to the limit, rather than its theoretical peak capacity. Let's start with the casual user. If you primarily rely on navigation, chat apps, and social media, your limits are strictly defined by software. We ran a live map rerouting test to see how quickly the phone adjusted to a missed turn. The performance on 4G and 5G was completely identical. This matrix shows how much data standard apps actually consume in the real world. Software developers write hard limits into their applications to save on their own server processing costs, creating a ceiling right around 50 megabits per second. A pipeline pumping 812 megabits of data is physically unusable by an app programmed to process a maximum of 50. Mobile gamers have hardware demands that differ entirely from casual app users. Gamers don't care about raw bandwidth. They care about latency, or ping, which measures exactly how fast the first piece of data makes a connection to the server. During competitive gaming, a standard 4G network creates a slight but noticeable delay between your tap and the server's response. We measured that baseline 4G latency right at 40 milliseconds. When we switched over to the 5G connection and ran the exact same test, the ping dropped in half to 20 milliseconds. 20 milliseconds is the response time you expect from a hardwired fiber optic line directly inside your house. Competitive players use 5G to gain the responsiveness of a hardwired connection while remaining on a mobile network. Next is the creator. You shoot high-resolution footage and you need to upload massive files straight from your phone. We initiated a transfer of a single 1.83 gigabyte video document. On the 4G network, the transfer hit a wall. It stalled completely at 18% capacity. It required 9 minutes of waiting just to fail, block the transfer, and force a manual restart. We put the exact same 1.83 gigabyte file on the 5G network. It hit 100% in exactly 5 minutes without a single hiccup. Finally, we tested the most demanding use case, a remote worker relying on a phone as a laptop hotspot. Hotspotting places immense hidden stress on your device. The phone has to route heavy external data to a laptop while simultaneously processing its own background data tasks. This split-screen chart compares how both networks handle an intense dual-load tethering stress test. Under heavy sustained load, the 4G network overworks the hardware, thermally throttling output down to 5 to 6 megabits to protect internal components. The 5G architecture handles the identical load cleanly. It delivers 256 megabits per second without ever triggering the phone's thermal choke point. When you are pulling down large work assets or 4 gigabyte apps, that thermal efficiency turns an 11-minute wait into a 3-minute wait. It also eliminates the loading buffer. Scrubbing back and forth through a 4K video over 5G feels natively saved to the device. The sustained stability of 5G allows a smartphone to function as a primary router for professional remote work, even under heavy data loads. The data shows a clear reality. 5G is a targeted infrastructure upgrade. It is not a universal solution for all smartphone users. This decision flowchart maps exactly who should upgrade. If your usage is primarily social media, messaging, and maps, stick to 4G. Software caps render 5G useless for casual tasks. But if your workflow involves tethering laptops, competitive gaming, or large uploads, aggressively pursue 5G. It is the only way to avoid the thermal choking and timeout failures that older networks suffer under heavy, sustained loads. And if you decide your habits don't justify the upgrade, you still get a hidden benefit. As heavy users migrate to 5G, the older 4G network naturally clears up, running faster for everyone who stays behind. Stop looking at raw speed numbers. Your daily habits, your workflows, and your specific software bottlenecks are the only metrics